Hey everyone, welcome back to another CIE A-Level Maths past paper video. Today we're going to talk about paper 112 from the October-November 2024 series. So let's jump into the paper. Question number 1. The diagram shows the curve with equation y is equal to a sine bx plus c for 0 less than x to 2 pi. Okay, where a, b, c are positive constants. State the values of a, b, and c. Okay, so a can be found from the maximum and minimum divided by 2. So a is basically okay, we can first define that. So basically this is your offset or the mean position. This is our amplitude, and this is a factor related to the period, so we need to figure that out. So C is so if we first figure out the max value, which is 7, min is -1, so C is max plus min divided by 2. 7 plus -1 divided by 2, 6 divided by 2, 3. Similarly, A will be just like this, but max minus min. So max minus min, peak to peak, divided by 2. So this is 7 minus -1, that is 8, divided by 2, 4. Now we need to find out B. So B seems to be 1 because no. There are two waves. As you can see, there are two waves in 2 pi. That's what we just need, right? So B is, or for example, the period of this, which is pi in this case, it's actually 2 pi over B. Right, so B is simply 2 pi. Another way to see this is that the scaling factor, horizontal scaling factor, is times by 2 basically. So this is your, if this was a function, this would be like 2x. So you have therefore A is 4, B is 2, and C is 3. Okay. For these values of a, b, and c, determine the number of solutions in the interval 0 to x to 2 pi for each of the following equations. A sine bx plus c, 7 minus x, and 2 pi x minus x, 1. Okay, so first we need 7 minus x. So 7 minus x would go... So the y-intercept is 7, definitely, but how do we figure out the x-intercept? Where y is equal to 0, that would be x is equal to 7. But we don't have 7 over here. So, okay, wait. I think we can find out a particular point over here. So if we do, for example, x is equal to pi, y can be 7 minus pi, and if we figure out what y minus 7 pi is, that is 3.858, roughly around 4, somewhat like this. So I think we can draw the line almost like this, like this, right? So 7 minus x will have how many solutions? We have 1, 2, 3, 4, 5. So 5 solutions. Okay, so 5. 2 pi x minus 1. Okay, so similar process we would do. Y is equal to 2 pi x minus 2 pi. So this means that minus 2 pi is your y-intercept, which we cannot draw over here for obvious reasons. We need to figure out another way. So let's plug in x is equal to, let's say, half pi. Let's see what we get over here. So if we plug in x is equal to half pi, you get 2 pi times by half pi. It's 2 pi x minus 1, right? Minus 1 minus 2 pi. So you get pi squared minus 2 pi. Okay, that's even weirder. Okay, we can figure out other points. This is not like, we can't locate that easily. So what if, for example, let's say x is, we need it in terms of pi. Okay, we can like choose simple numbers also. For example, where x is equal to 1, you have 2 pi minus 2 pi. Y is equal where x is equal to 1, 2 pi minus 2 pi. Oh yeah, so y would be 0. Okay. And let's say where x is equal to 2, you have 4 pi minus 2 pi, which is 2 pi. We still cannot go through that. Okay, but anyways, let's try that. So this is 3.141, and half pi is 1.5 roughly. So we need to figure out where 1 is, right? So we can figure out the scaling, right? So if pi is distributed over 4 boxes or 4 units, how much would we have in for 1, right? So 4 over pi basically. 4 over pi, 1.2. So roughly like there over here, okay? And for 2, let's say this thing, same thing. So 8 over pi times by 2, you can say. So this would be 2.5 roughly. So 2.5 I think this one. Oh yeah, okay. And this times by 2 pi. So where is 2 pi? So 2 pi is 6.2. That is 6.2 roughly over here. Okay. So now if we draw the line, okay, okay. So as you can see, this is roughly the estimate of this line. So there is only one solution for this. Okay, that's it. All right, let's move on to the next question. Question number 2. The first term of an arithmetic progression is minus 20 and common difference is 5. So A is minus, actually we should write over here, minus 20. D is 5, okay? Find the sum of the first 20 terms of the progression. So S20 will be, we have n over 2, 2a plus n minus 1 d, right? So 20 over 2, 2 times by negative 20 plus 5 times by 20 minus 1, that is 19. So 10 times by minus 40, and 19 times by 5, that is 95. So 95 minus 40 times by 10, which is 550. It is given that the sum of first two k terms is 10 times the sum of the first k terms. Find the value of k. Okay, so first we need to figure out s2k, an expression generally. So n over 2, 2k over 2. A and D are the same, right? So 2 times by A plus 5 times by 2k minus 1. So let's further simplify this. So k minus 40 plus 10k minus 5. So this is k times by 10k minus 45. Right, okay. Now we need s of k. That is k over 2 times by 2 times by minus 20 plus 5 times by k minus 1. So this is k over 2 minus 40 plus 5k minus 5. So you have k over 2, 5k minus 45. Okay, so it's saying that the s2k is 10 times the sum of first k terms. Okay, so s of 2k is 10 times by s of k. So you have k 10k minus 45 is 10 times by k of 2, 5k minus 45. Okay, so first off we can cancel out this k and k. So you can get 10k minus 45 is equal to 5 times by 5k, which is 25k, and 5 times by 45, which is 225. Okay, alright, so 25 minus 10, 15k, and 225 minus 40, 180. So k is 180 divided by 15, so therefore it's 12. Okay, and that's it for this question. Let's move on to the next one. Question number 3. The equation of the curve is y is equal to 2x squared minus 3. 2 points A and B with x coordinates 2 plus h respectively lie on the curve. Find and simplify an expression for the gradient of the chord AB in terms of h. Okay, so we're going to treat it as a function, right? So f of 2 is 2 squared minus 3, which is 8 minus 3, 5. F of 2 plus h would be 2 plus h squared minus 3. So we are going to write it as 4 plus 4h plus h squared minus 3. 8 plus 8h plus 2h squared minus 3. So that becomes 5 plus 8h plus 2h squared. Okay, so gradient would be f of 2 plus h minus f of h, sorry, 2 divided by h, right, because 2 plus h minus 2. So you will get this minus this, so that you will only get 8h plus 2h squared divided by h, which can simplify to h plus 2h. 8 plus 2h, sorry. Now this is the simplified expression for the gradient. Okay, explain how the gradient of the curve at point A can be deduced from the answer to part A and state the value of this gradient. Okay, so when h approaches 0, that means we write it as h approaching 0, the average gradient becomes this thing, the secant value, the gradient value becomes more accurate, it becomes tangent. So basically chord AB approaches or almost becomes tangent AB, tangent at A basically. So we need the value, we make h approach to 0, so gradient would be, you see, h would approach to 0, so you will get just h. Alright, that's it for this question. Let's move on to the next one. Question number 4. Find the term independent of x in the expansion of each of the following. Okay, so you see, if we write the general form of general form of each term in this, that is going to be 6c, let's call it n. You have x raised to power n and 3 over x squared, which can be written as 3x minus 2 raised to power 6 minus n. Okay, where n goes from 0, 1 up till 6. Okay, so the powers of x, basically we need to figure out where they become 0. So powers xn times by x minus 2, 6 minus n, this becomes x raised to power 0. So simplify further, this is x raised to power n times by x raised to power minus 12 plus 2n equals to x raised to power 0. So again, if you just equate the powers, you will have n plus minus 12 plus 2n equal to 0. This means that 3n is equal to 12. That means n is equal to 4. Okay. Now we need the full term, right? The full term, correct? So the term would be 6c4. Obviously there will be no power of x, right? Independent of x, right? But 3 raised to power 6 minus n, that would be 6 minus 4 squared. That would be the case. So you have 6c4 times by 9, that is 135. Okay. Now, right. Okay, so we are going to perform the same operation with this one. Okay. However, there are two factors where this expansion is multiplied. So we have to choose different things for that. So where this is multiplied with this first, and where this is multiplied with minus 5. So the minus thing will happen. So basically what I'm saying is you have 6cn x raised to power n. We only need the powers of n, right? We only need powers of n times by x minus 2, 6 minus n, times by x cubed minus the constant one, right? Let's call it 6c, right? So this will be handled differently, and the constant where it multiplies with the 5, that will be same thing as this one, but with the negative 5. So negative 5 times by 135, basically, right? So now we need to figure out where this is happening. where you multiply the x cubed, which value of n would satisfy with that. So you have x raised to the power n times by x cubed, and this was minus 12 plus 2n minus 12, x raised to the power 0. So you have 3 plus n plus 2n minus 12 equal to 0. You have 3n, 12 minus 3, 9. So n is equal to 3. So this becomes 6c 3. Since it is just independent of x, we just need the power of 3. 6 minus n, that would be just 3 times by 4, right? Because at the end of the day it's going to be independent. So 6c3 times by 3 raised to the power cubed times by 4, this is 2160. So term independent of x is 2160 minus 5 times by 135. That is 1485. And that's about it. Let's move on to the next question. Question number 5. The function f is defined by f of x 2x plus 1 divided by 2x minus 1 for x less than half. State the value of f of minus 1. So basically f of minus 1 is equal to 2 minus 1 plus 1 divided by 2 minus 1 minus 1. So minus 2 plus 1 and minus 2 minus 1. So that is minus 1 minus 3. That is just 1 over 3. Okay. The diagram shows the graph of y is equal to f of x. Sketch the graph of inverse y is equal to f inverse of x on this diagram. Show any relevant mirror line. Okay, so the mirror line is basically y equals to x. So this is your y equals to x mirror line. So since this, like, it's just swapped, this will be where the lines are meeting. Let's choose a different color. This is where the lines will be meeting, the functions will be meeting. This is minus 1 over here, so this is where the graph will cross, or over here on the x-intercept. And any other feature? On this side it will cross over here. Okay, so let's try. And this is almost 1, so it will come over here, and this will come over here. Right, that's it. So this is, the graph is crossing, let me just clarify, over here, and right over here. Okay. Find an expression for f inverse of x. State the domain of the function f inverse of x. Okay. Right. So we have y equals to 2x plus 1, 2x minus 1, right? Yes. Okay. So we cross multiply 2x minus 1 times by y equals to 2x plus 1, 2xy minus y equals to 2x plus 1. We make x the subject, so 2xy minus 2x equals to y plus 1, x 2y minus 2 equals to y plus 1. Therefore, this becomes x equals to y plus 1 2y minus 2. So this becomes f inverse of x plus 1 2x minus 2. Right? Okay. Now we need to figure out the range now, right? Sorry, domain now, right? For the domain of f inverse, the range of the original function becomes the domain of that. So we just simply need to figure that out. We can actually figure this out by doing some long division on this, right? That would be that would be more appropriate. So if you have f of x, 2x plus 1, 2x minus 1, we need the long division. 2x plus 1, 2x minus 1, so you get 1 times by that. You get 2x minus 1 minus, you get 2, right? So this can be written as 1 plus 2 over 2x minus 1. So as you can see, this is a reciprocal function where 1 is your horizontal asymptote and this thing, the vertical asymptote, will be x is equal to 1 over 2 would be your vertical asymptote. Okay, so the range of f of x is just simply f of x less than 1. So that means the domain of f inverse of x will be also less than 1. Okay, and we have actually shown that also, right? We have actually shown that also. So this is where the vertical asymptote will be. Alright, that's it. Let's move on to the next question. Oh no, sorry, we have this part. Okay. The function g is defined by g of x, 3x plus 2. Solve the equation f of x, g f of 1 over 4. Okay. f1 over 4 is 2, 0.25 plus 1, 2, 0.25 minus 1. So we have 0.5 plus 1, 0.5 minus 1. So that is 1.5 over minus 0.5. So 1.5 divided by minus 0.5, this is minus 3. Okay, so g of minus 3 now would be 3 minus 3 plus 2 minus 9 plus 2 minus 7. We don't just need that, we need the f of x equals to that. Okay. So where the f of x 2x minus plus 1 over 2x minus 1 is equal to minus 7. So we need to find the value of that. So 2x plus 1 equals to minus 7. 2x minus 1. 2x plus 1 equals to minus 14x plus 7. 14 plus 2 is 16x. And 7 minus 1 is 6. 6 over 16. So divided by 2, this would be 3 over 8. Alright, that's it. Let's move on to the next question. Question number 6. The diagram shows a metal plate O, A, B, C, D, E, F consisting of sectors of two circles, each with center O. The radii of sectors AOB, EOF are r centimeter, and the radius of sector COD is 2r centimeter. Okay. It is given that the perimeter of the plate is 14 centimeter and the area of the plate is 10 centimeters squared. Given that r is greater than 3 by 2 and theta is less than 3 by 4, find the value of r and theta. Okay, so we need the expression of, because we have two unknowns, r and theta, so we need two different expressions. That means they will come from perimeter and the area. So, okay, area half, like this is half r squared theta, this is half r squared theta, this area half r squared theta in radians times by 2 plus half 2r squared 2 theta. Okay, this is equal to 10. You get 2 cancel out, so you get r squared theta, and you get 4r squared theta. This means that this is your 5r squared theta equals to 10, which means your r squared theta is 2. Okay, now we work with the perimeter. Okay, so first we need the arc lengths. R theta, okay, so r theta plus r theta plus r theta plus this arc length, so 2r times by 2 theta. Okay, now the lengths of the sides, this would be r and r also. Okay, so 4 times by r. Right. Okay, and that is equal to 14. Okay, so you have r theta, and this is 4r theta, so this becomes 4 plus 2, that is 6r theta plus 4r is equal to 14. And r can be taken out and divide by 2. So 3 theta plus 2 equals to 7. We can make theta is equal to 2 over r squared. So you have r 6 over r squared plus 2 equals to 7. So you get 6r over r squared plus 2r equals to 7. Cross multiplied r squared across, you get 6r plus 2r cubed equals to 7r squared, right? And we can drop 1r because r is equal to 0 is a trivial solution, so it's 6 plus 2r squared is equal to 7r. Okay, now this is a quadratic equation. 2r squared minus 7r plus 6 equal to 0. Right, so let's see if we can figure this out using sum and product. So this is 6, this is minus 7r, this is 2r squared. There's only one way you get 2, but 6 you can get from 3 and 2. 2 and 3, no. 6 and 1, no. 2, 3, 4 plus, oh yeah, sorry, I did it before, sorry. If both of them are negative, okay, so 2r minus 3 r minus 2 equal to 0. So r is either 3 over 2 or r is 2. Okay, so they gave us condition that is r is greater than 3 over 2. So that means therefore r is 2. Now we can find out theta, that is 2 over r squared. So 2 over 4, that is half radians. And that's it for this question. Let's move on to the next one. Okay, so question number 7. By expressing minus 2x squared plus 8x plus 1 in the form minus a x minus b plus c, where a, b, c are positive integers, find the coordinates of the vertex of the graph with the equation. Alright, so first off, we can take minus 2 out in this. You take minus 2 out, this becomes x squared minus 4x plus 11. Right? Minus comes out, this becomes minus 2x plus 8x plus 11. Okay. Then, notice that this is the square, like this is the expression we need to complete the square for. So we do minus 2 x squared minus 4x plus 2 squared minus 2 squared plus 11. So this minus 2 squared will come out, but it first has to multiply with this minus 2. So so this will become minus 2 x squared minus, x minus 2 whole squared. Then this minus 2 multiplied by this minus 4 becomes plus 8 plus 11. And finally this would become minus 2 x minus 2 whole squared plus 19. So therefore the vertex would be x is equal to 2, y equals to 19. You can also write it as 2, 19. Okay. B part. The diagram shows part of the curve with the equation y is equal to minus 2x squared plus 8x plus 11, and the line with the equation y is equal to 8x plus 9. Find the area of the shaded diagram, shaded region. Okay, so first off we need to find out where the intersecting points are. Okay, so first off we need to find the intersecting points, and I think we can try to find it from this thing. No. Okay, so either way that would be fine. 8x plus 11 equals to 8x plus 9, or you can try doing 2x minus 2 whole squared plus 19 equals to 8x plus 9. This way would be a little bit straightforward. Over here you will have to expand the square anyway. Right, okay, so this becomes minus 2x squared. As you can see, 8x will get cancelled, and this becomes actually we can take 11 on the other side. 9 minus 11, that is minus 2. Minus minus gets cancelled. X squared equals to 1. That means x is plus and minus 1. Okay. This is the quadratic function, and this is your 8x plus 9. So that means it's area minus area between these two regions. So area is from minus 1 to 1 minus 2x squared plus 8x plus 11 dx minus, actually you could lump them into one integral also, but let me show you first. Dx from minus 1 to 1. Alternatively, what you could have done is minus 1 minus 2x whole squared plus 8x plus 11 minus 8x plus 9 dx. Either way that would be fine, but the second way is more straightforward. Let's first simplify this. You have minus 2x squared, 8x minus 8x minus 8x will get cancelled, 11 minus 9 will become plus 2 dx. Okay, now we integrate this. This would become minus 2x cubed over 3 plus 2x from minus 1 to 1. Right, okay. Now we plug in the limits. Minus 2 over 3, 1 plus 2 times by 1. Then you have minus 2 over 3 minus 1. Minus 1 cubed is just simply minus 1. Then you have 2 minus 1. Minus 2 over 3 plus 2 minus, this just becomes 2 over 3 minus 2. So this becomes minus 2 over 3 plus 2 minus 2 over 3 plus 2. So this becomes minus 4 over 3 plus 4. 4 minus 4 over 3. And in what form do we need it? Find the area of the shaded region. That means we want an exact answer. So let's just simply do that. To make denominators constant, this becomes 12 minus 4, 8 over 3. Alright, and that's it for this question. Let's move on to the next one. Question number 8. The equation of a circle is written as this, where P and Q are constants. Express the equation in the form this. That means we need to complete we need to complete the squares for these things. So first off, we do x squared plus px plus y squared plus 2y, and q goes on the other side. Right? Okay. Now we need to complete the square for these. So x squared plus px plus p over 2 whole squared minus p over 2 whole squared brackets plus y squared plus 2y plus 1 squared minus 1 squared equals to minus q. Alright, so we continue. This becomes x squared plus p over 2. This would become x plus p over 2 whole squared minus p squared over 4 will go on the other side, and plus y plus 1 whole squared minus q plus p squared over 4 plus 1. Okay, and r squared to be given in that form. Okay, I think that's fine. However, notice that they're given as minus a and minus b. So right, okay, so we can convert it into x. minus p over 2 whole squared plus y minus minus 1 whole squared equals to 1 minus q plus p squared over 4. Sorry, p squared. And that's it. All right. The line with the equation x plus 2y equals to 10 is tangent to the circle at point A, 4, 3. Find the equation of the normal to the circle at point A. Okay, so the normal to the circle at point A will actually be passing from A to the center of the circle. Okay, so that's how it will actually go. So you have this, let's say this is the point A, this is your tangent. Okay, let's say this is your tangent, this is point A. The normal to this line at A will actually be passing through the center. So if we want the equation to the normal, we know the center point. Okay, that is a minus p over 2 minus 1, and this point is 4, 3. Okay, so this is passing through the center. Okay, and they've given us the equation of the tangent. That means we have the gradient of the tangent. Okay, so we need to dissect that. So you have y equals to, 2y is equal to minus x plus 10. This becomes y equals to minus 1 over 2x plus 5. So now the gradient of normal is just simply 2. So equation of normal would be y minus y1 mx minus x1. So we know that it's passing, the equation is passing to the center and point A. So y minus 3 2 2x minus 4. So okay, let's make it into y is equal to mx plus c form. So this is y equals to 2x minus 8 plus 3. So therefore it is y equals to 2x minus 5. Okay, find the values of p and q. Okay, so notice that this equation passes through the center. Okay, not only that, but the distance between this and the center point is the square of that. Sorry, is the square root of this r squared. So two unknowns, therefore two conditions do we need to solve it. Okay, so normal passes through the center minus p over 2 and minus 1. So we know that we have the equation y is equal to 2x minus 5. So we plug this point in, that is minus 1, 2 minus p over 2 minus 5. The 2 and 2 get cancelled. You have minus 1 minus p minus 5. So p would be minus 5 plus 1, which is minus 4. So that is p. For q, we basically need the expression for the circle. We know that radius is distance from 4 comma 3, 2, and now the center is minus p over 2, so that would be just 2 minus 1, right? So minus 4, so minus 4 over 2, so that is just 4 over 2, 2 comma minus 1, 2 comma minus 1. So you have r squared is equal to 4 minus 2 whole squared plus 3 minus 1 whole squared, right? 4, 3, right? Yes, okay. So you get 4 minus 2, 2 squared is just 4. 3 plus 1, 4. 4 squared is 16. So that is 20. We just need r squared. So r squared was also 1 minus q plus p squared over 4. That is equal to 20. So therefore, p squared over 4 minus 4 squared over 4, that is just simply just 4. 16 over 4. 1 minus q plus 4 equals to 20. So q would be 5 minus 20, which is minus 15. So therefore, p is minus 4, q is minus 15. Right, okay. That's it for this question. Let's move on to the next one. Question number 9. The equation of the curve is this, and the equation of the line is this, where k, p are constants with 0 to k to 1. Okay, k between 0 and 1. Okay, it is given that one of the points of intersection of the curve and the line has coordinates this. It is find the values of k and p, find the coordinates of the other point of intersection. Right. So that means we can find k and p by by plugging it into this equation, because this only has just k, this has k and p, right? So okay, so first we need to find k and p, right? So you have 5 over 2, 1 over 2. So we plug this into y equals to half k squared. X squared is 5 over 2 whole squared minus 2k, 5 over 2 plus 2, and this is equal to 1 over 2. Sorry. Okay. 1 over 2 k squared, 5 over 2 whole squared, minus 2k, 5 over 2 plus 2. Okay, let's simplify. 1 over 2 k squared over 2, 25 over 4, minus 2 and 2 gets cancelled, so 5k plus 2. So this becomes 8. So we have the equation in k. Okay, so what we can do is we can multiply both sides by 8, because you have 2 times by 4, 8. So 8 divided by 2 is 4. This becomes just 25k squared minus 5 times by 8, 40k, and 16. So this would become 25k squared minus 40k, and 16 minus 4, 12. And further, no, sorry, this is 25k squared. Okay. Alright, so now let's see what we can do. Let's try to solve this with the sum and product rule. So you have product is 12, sum is minus 40k, this is 25k squared, You only get 25 by doing 5k and 5k. Let's try with 3 and 4. So 20, 15, no. 6 and 2. 30, yeah, so 30k and 10k. So both of them have to be negative. Okay, so you get it by doing 5k minus 6, 5k minus 2. So you get either 6 over 5 or k is equal to 2 over 5. They gave us some condition between 0 to 1. That means therefore this will be discarded. So therefore k is 2 over 5. Okay, now we need the p. So we plug in the y is equal to kx plus p. Same point, 1 over 2 in y is equal to kx plus p. So we plug in 1 over 2, 2 over 5, 5 over 2 plus p. 2 gets cancelled, 5 gets cancelled, so basically p is 1 over 2 minus 1, which is minus 1 over 2. So therefore p is minus 1 over 2, k is 2 over 5. So now we have two equations, y equals to half k squared, so that means half k squared is 2 over 5 whole squared plus x squared minus 2kx, so that means just simply minus 4 over k x and plus 2 equals to kx plus p, so that is just 2 over 5x minus 1 over 2. Okay. So if we multiply both sides by 10, let's see what we get. So when we multiply both sides by 10, this becomes just simply 4x squared. 10 divided by 5 is just 2. 2 times by 4, 8x plus 20 equals to 5 times by 2, so 2 to 4, 4x and minus 5. So 4x squared minus 12x plus 25. So 4 is the square of 2, 5 is so 25 is the square of 5. So 2, 5, but this is not the, okay, let's see what we are dealing with over here. So this is 25, this is 4x squared, but this is 12. 5, 5, 2, and 2. Sorry. 10 and 10. Okay, so what now we can do is simplify. So this is 1 over 2, 4 over 25, x squared minus 4 over 5x plus 2 equals to 2x over 5 minus 1 over 2. Okay, alright. Should we multiply this by 50 on both sides? No. Just 25. No. Okay, anyways, let's further simplify this, and then we'll see what we need. Yeah, so let's multiply this by 50. Okay, so when we multiply this by 50, this becomes 2x squared minus 10 plus 100 equals to 20x and minus 25. 4x squared, right? So 2 over 25 times by 50, this will become this. So then we will get 4x squared minus 40 minus 20 minus 260x and minus 125x, okay, equals 0. Now we need, so 4x squared minus 125 minus 60x, so this is 25 times by 5. Yeah, so 50x, 10x if they're both, no. Only one of them has to be negative. Okay, no, that means this will not work. Sorry, I just realized this is plus 125. Now if this was, then you have 5 times by 25. So now, sorry, that was the mistake. So minus 50x minus 10x. Okay, so you have now 2x minus 5, 2x minus 25 equal to 0. So either x is 5 over 2 or x is 25 over 2. So that means we need to follow through this. Y equals to kx plus p. So k was 2 over 5. 25 over 2. P was minus 1 over 2. So 2 gets cancelled. 5 times by 5. 5 minus 1 over 2 is 4.59 over 2. So other coordinate is 25 over 2, 9 over 2. Okay, it is given instead that the line and the curve do not intersect. Find the set of possible values of p. Okay, so this means that the previous condition that we had is now not used. Okay, so let's write the equation. Half k squared x squared plus 2kx, or minus 2kx, sorry, 2kx plus, what was the third thing? 2 equals to kx plus p. Okay, alright. We multiply this by 2. We get k squared x squared minus 4kx plus 4 equals to 2kx plus 2p. Now we rearrange k squared x squared minus 6kx, and then you have 4 minus 2p. 2p equal to 0. Okay, so let's figure out the determinant. B squared minus 4ac is less than 0, but we have two unknowns. Let's see where this goes, and then we can see what we need. Okay, b squared is 36 k squared minus 4 k squared 4 minus 2p less than 0. 36 k squared minus 16 k squared plus 8 k squared p less than 0. K squared is a common factor, so we can reduce that. 36 minus 16 is just 20 plus 8p less than 0. So p is less than 20 over 8, which is 5 over 4. Sorry, 5 over 2. Yeah, that's it. Oh, that's it. Alright, so that's it for this question. Let's move on to the next one. Question number 10. A function f with domain x greater than 0, it is given that the curve with the equation y is equal to f of x passes through the point 1, 10. Find the equation of the normal to the curve at point 1, 0. Okay, alright. We need to figure out what's at 1. What the gradient is at 1. So 8, 2 minus 3, 1/3, minus 10, 1, 2 over 3. So any power of 1 is just 1. So cube root of -1 is just -1, and any power of positive 1 is just 1. So minus 8 minus 10, that is minus 18. So gradient of normal is 1 over 18. Okay, so now we do the equation of normal. Y minus y1 m x minus x1. So you have y minus 0, 1 over 18, x minus a1. That's it. So y equals to 1 over 18x minus 1 over 18. That's it. Okay, find f of x. Okay. Okay, we need to integrate that. So integral of 8 2x minus 3 1 over 3 minus 10x 2 over 3 dx f of x. Okay, so 8 will remain as it is. Power on 2x minus 3 will increase by 1. So 4 over 3. We divide by 4 over 3 and times by derivative of 2x minus 3, 2. The reverse chain rule basically. Then we do the same thing with this. So a 10x 2 over 3 plus 1, 5 over 3, divide by 5 over 3, and that's it, plus c. So 8 divided by 8, this would be 6. So 8 times by 3, 24, 24 divided by 4, 6, divided by 2, 3. So 3, 2x minus 3, 4 over 3, 30 divided by 5, 6, x 5 over 3 plus c. We plug in 1, 0. F of 1 is equal to 0. So f of 1 is 3. 2 minus 3, 4 over 3 minus 6 x 1 over 3, sorry, 1 5 over 3 plus c, that is 0. So any positive power, so 1, so you see minus 1 cube root is just minus 1, but minus 1 raised to power 4 is just positive 1. The 3, same goes with this one. Any power positive 1 will just remain positive. C is equal to 0, so C is 3. Right. Okay, so f of x would be 3, 2x minus 3, 4 over 3 minus 6x, 5 over 3 plus 3. Okay, now the b part. It is given that the equation f prime of x equals to 0 can be expressed in the form. Okay. Determine, making reasoning clear, whether f is an increasing function, decreasing function, or neither. So basically they have reduced the f prime of x equal to 0 into this quadratic function. That means we can find the stationary points. So the nature of that stationary point can tell us whether it's an increasing function, decreasing function, or neither. Okay, so let's see that. If we try determinant b squared minus 4ac, 128 squared minus 4, 125, 192, 128 squared minus 4 times by 125 times by 192. Now this is negative. Okay, so negative. Therefore no turning points. However, this is not for the original function, this is for the f prime of x. Okay, we need to give the reasoning for f. Okay, so there are no turning points or like nothing for f prime of x, so we don't know directly. So what we can do is we can check this one. So what we know over here is that since the gradient itself has no turning point, so it's changing in one direction only. So it's changing in one direction only. Okay, so there is no turning point for that. So either it's an increasing function or a decreasing function, but it's not changing. The gradient is, we're not saying that the gradient is constant, we were saying that the direction of that gradient is not changing. So now we need to deduce whether, so if it's not changing, that means the sign of the gradient that we had over here, that is more than enough for us. So since f prime of 1 was negative 18 and f prime of x is not changing direction, therefore f of x is a decreasing function. Right? So basically what's happening is sort of like this. It's So So sort of like this, not a straight line, but the gradient or the function is decreasing. Either it's this way or like this way, but it's still decreasing. But the sign of the gradient is not changing. Okay, so you can say that the gradient is not changing direction or sign, because we showed that over here that it's not changing direction. There is no turning point for direction. So that's the reasoning for this. And that's it for this paper. I hope you enjoyed the explanations and were sufficiently enlightened. If you have any problems or confusions, feel free to reach out in the comments. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. And if you would like to have a one-on-one coaching, in case you like the way I teach, you can also apply for that. The links are given below the video and in the description. Just reach out through the WhatsApp or any of the social links, and we'd love to help you out. Until the next video, take care. Bye-bye.